All right, today we're covering topic 6.5, which is interpreting integrals as a rate of change. And this first problem gets us started, and we're looking at the graph of a piecewise function that's shown in the figure. And the function is defined as the integral of a function. And so we have to consider it that way. They ask which of the following values is greatest. So on all of these values, we have to plug the number in for x in this integral, all right? So if I'm finding g of negative 3, I have to put the negative 3 in for x. The bottom limit is a negative 2, which tells me right away I need to flip the limits of integration and put a negative in front of it. And so we're just looking at this area here, but because of this negative, this is some kind of negative value. And that's all we really care about right now, is that it's negative. All right? So that's letter A. We know it's a negative value. Letter B is g of negative 2, which makes it the integral from negative 2 to negative 2, which we know is 0. All right, that's fairly easy. Letter C is g of 0, and I will make this one in red. So we're going from negative 2 to 0. We're going from negative 2 to 0, so that's this area in here, which definitely is some kind of positive value. That's our biggest value yet out of this one, and this one. All right? But when I look at letter D, all right, letter D is g of 1, which means that I'm doing the integral from negative 2 to 1. So that means coming clear over to here for this area, and that's even bigger. All right? So that means so far, letter D is the biggest. What is g of 2? We need to check letter E. G of 2 is going to be the integral from negative 2 to 2. 2 is here, which means I have to consider this negative area right here. So this negative area and this positive area are going to cancel out, and it's just going to be the area of this. So letter E is smaller than D. So the answer is definitely letter D. This problem is actually a pretty quick problem. All right. They tell us that the graph, the figure above, is the graph of f, and they tell us that f of x is the integral from 2 to x of g of t dt. All right? And then they ask, which of the following could be the graph of y equals g of x? Well, the best way for me to get to g of x is to find the derivative of f. F prime of x, we know from topic 6.4, is just going to be g of x. All right? So if I look at the derivative of this function, f prime of x, this is a linear, this one is a linear, and we know that the derivative of any linear is a constant. So it's definitely letter A. This next problem is really not that bad once we know what I have here in this box. Position at the end minus the position at the beginning. We have an object traveling in a straight line with the position x of t. If the initial position is x of 0 equals 2, x of 0 equals 2, that's going to be important for us. X of 0 equals 2 will be important for us. And they give me the velocity. What is the position of the object at time t equals 3? Well, let's make some more room here. I know the position at the end is going to be x of 3. If I subtract the position at the beginning, that's going to be x of 0. That will be equal to the integral of the velocity function, which they gave me, the cube root of 1 plus t squared dt from 0 to 3. Because remember, if we integrate velocity, if I integrate velocity, I get position. All right? This side over here on the right, this we can just use the TI-84 and do Math 9. This value over here is 4.512. I'm looking for x of 3 because we want the position of the object at time 3. They give me x of 0, which is 2. So I just have a simple algebra equation. The position of the function is 4.512. Remember, we got, I'm sorry, it is 6.512. We need to add 2 to both sides. Remember that I got this value using Math 9 on the right-hand side. Okay? One last thing, couple things just cleaning up here. On question 26, they are asking me some questions about whether it's increasing, decreasing. Well, just a reminder that if a function is increasing, then g prime is positive. All right? So they give me g prime as the integral of this function. Well, I'm going to tell you that e to the negative x squared looks like this. All right? If you put that in your graphing calculator, that's what it looks like. And if I want to know if it's increasing from 0 to 2, I can look at 0, 1, 2. What is this area? It is most certainly a positive area, so it is definitely increasing. So we're definitely looking at either letter A or letter B. Now we need to talk about concavity. Well, when we do concavity, we look at the second derivative. All right? So g double prime is going to be the derivative of our integral, which will just be e to the negative x squared. And when we look at concavity, we're wondering, are the function values positive or negative? Well, all of these function values on e to the negative x squared are positive from 0 to 2. So it most definitely is concave up. So it's letter A. Now, on this problem, this last problem that we're going to look at today, they give you this piecewise function that has all these geometric figures. So if they ask me to find the value of g of 2, g of 2 will be the integral, all right, from 1 to 2 of the function. Well, that's just this little area right in here. That's just an area. And of course, it's going to be negative. So you can just do the little area calculation on the triangle. If they ask me to find g of negative 2, well, now I'm doing the integral from 1 to negative 2. I need to put a negative in front of it to get my limits of integration in the right order. So now I'm doing the area from negative 2, which is right here. All right. Sorry, negative 2 is right here. Over to 1, which is right here. So I need this area, and then I need this negative area in here, and that will tell me what g of negative 2 is. And we will stop the video there for today.